Hello everybody, today we're doing a LeetCode daily problem. This is find first and last position of element in sorted array. So our task is we're given an array of numbers, all integers, in sorted order, and we have to find the starting and end position of a target value. If it's not found, return -1, -1, right? So if we look at this array right here, so we need to find the position of the first 8 and the second 8. So of course the naive solution is just going to be to iterate through this array, right? Find the first 8, keep going until we find a number that's not 8, and then return these two positions, right? The position of the first 8 and the position of the number before the first non-8. And if we find no of our target, like this example, we return -1, -1. But of course the follow-up says they want us to do it in O of log n time. So we're going to skip the naive solution, go straight to something that does it in O of log n time. So we're doing this in Python first, and then we'll move to C++ later on. The first solution I'm going to give is one that uses a library, right? So we can use Bisect, which is a standard library. And what Bisect is going to do is it's going to, we're going to use two different versions, Bisect left and Bisect right. So Bisect left is going to tell us if we had 8, right? If we want to insert 8 into this array and have it be the first 8 in the array, where would we put it? Okay, what index would we put it? So that would be this index right here, index 3. And Bisect right is going to do the opposite. It's going to say if we want to insert it and make it be the rightmost 8, where would we put it? So that would put us at 0, 1, 2, 3, 4, 5, right where this 10 is. So we would push the 10. So what we're going to do is we're going to bisect left first, right? And that's going to binary search and do that in log n time. And then using that index, we're going to bisect right using this left index as our lower bounds for our bisect right. Okay, so I'm going to do that right now and show you what that means. So left right equals bisect dot bisect left. And we need the array of nums, the target, and then no other parameters, okay? So that's going to give us our leftmost index. Our right index will be bisect right, nums, target, and then there's some optional parameters. We're going to put low is equal to L. What that means is that the second time we're bisecting right, we're actually only going to start and use this part of the array. So we're not actually going to even focus on these numbers because we don't need that part anymore. We're just going to speed ourselves up and only use part of the array for the second part, okay? Now we need to check and see if we actually found something. And how do we check? So we can return L r -1, right? So we want actually the index of this last 8, right? R is currently going to give us this index. So we're going to take right -1, and we can return that if R is not equal to L, okay? Because if these two are equal, that means that actually we didn't find the number we're looking for. So in this example, R and L will both be index 1, and because they're equal, we'll return -1, -1. Okay, so we'll return right L and R -1 if right is not equal to left, else -1, -1. Okay, so this solution is going to give us actually what we're looking for. So let's run that. Seems like the first test case went fine, and submit it. Okay, it was accepted. Looking at the details, we ran in 72 milliseconds. Although, so that's the first solution. We're going to go back and do that again, this time using. All right, so a library is all well and good, but maybe you're in an interview and they tell you can't use this library, even though it's the standard library, which you should be able to. Now, how to implement this on your own. So we're basically going to do the same thing. So we're going to bisect left first, and then we're going to bisect right, but we're going to implement them ourselves. Okay? So for the bisect left first, we're doing basically a binary search. So we need low and high equal to 0 and the length of nums, which is our array. Then we say while low is less than high, mid is equal to low plus high, then integer division by 2. Okay? And then we say if nums mid is less than nums mid is less than our target, then low is equal to mid plus 1, else high is equal to mid. So this is our standard binary search, right? We're looking for the lowest index of the target value. So if our number is higher than or is less than the target, then our low is equal to the mid plus 1, because the left half does not have our target. Else high is equal to mid, because the right half doesn't have our target. Okay, so we're going to end up with low equaling the target value. This is the same, right? So now L is equal to low, right? So this is basically the same as this bisect left function right here. We're ending up with the same value in L. Now, we're going to do the same thing with the right half. So we want to say that our high is again equal to the length of the array. So we'll say high equals length of nums. Then we'll say while low is less than high, mid, we're going to basically do the same thing. Equals low plus high, integer divide by 2, if nums mid, and now this is slightly different, is less than or equal to the target, right? Because we're finding the right side. Then low is equal to mid plus 1, else high is equal to mid. Okay, now this is actually going to be the same thing as this bisect right here. Okay, and low equals L. You can kind of see how this parallels here. We're starting with our low as the left side. Okay, and now I'm going to, for my convenience, say R is equal to low. Okay, so this is our bisect right, and I didn't even put it in the right place, right? This is our bisect right. Now we have L and R the same as we did up here. So we can do our return statement, return L R minus 1 if R is not equal to L, else -1, -1. Okay, so we have just implemented the same thing, right? So we have two function calls up here. These are basically the same two function calls. In fact, if I wanted to, make these, turn these into the functions, I could say, right, def bisect left nums target, right? And now in here, I'm just going to do this. Right? So I can say L equals low equals bisect left nums target. And we can def bisect right nums target low. Okay, we're going to do that. And then at the bottom, we can say R equals bisect right nums target low. Okay, so this is doing the exact same thing as our function calls up here. All right, I've added some return statements and cleaned it up a little bit. So now we're returning from each of these functions low. And we have down below exactly the same syntax as we have up here. And we've literally just implemented bisect left and bisect right as they are in the standard library. So if I run this, I get the correct answer. And if we submit, we get accepted. And let's check out the performance. Seems to this time have run a little bit slower than our library version, but that's okay. We are doing things by the book. So now that we have down our lower level solution without the library functions, we can just implement the same exact idea in a language like C++ and go for more performance. So let's go int low equals 0, int high equals nums.size. All right, and then we want to initialize int mid. So then we can say while low is less than high, mid is equal to low plus high. Divided by 2, we just have integer division. And then we say if nums, sorry, we need our parentheses, if nums mid is less than the target, then we can set low equal to mid plus 1, semicolon, and else high is equal to mid. Okay, so there's our bisect left. So now we say int L is equal to low, right? And then we can say high is equal to, we want to reset this to nums.size. And then we can say while low is less than high, the exact same thing, mid equals low plus high, divided by 2. And then we can say if nums mid is less than or equal to the target, we want to set low equal to mid plus 1, and then else high is equal to mid. You can say and r equals low, and then we can have an if else on our return. So we can say if r is not equal to L, return a vector int of our L, and then r minus 1. And then else, if they are equal, we want to return a vector int of -1, -1. And hopefully I got all my semicolons, and let's run it. It finished. 0 milliseconds. Got the correct answer. Let's submit. All right, our answer was accepted. We can check it out, see the stats. And since we're in C++, it's going to be a lot faster. This time we got 8 milliseconds. Kind of slow. Probably could have gotten it down to 0 if we optimized our code in some way. But that is find first and last position of element in sorted array. Hope you like this, and we'll see you next time.